Gross vehicle mass of a goods-carrying commercial vehicle is the sum of its tare mass and the mass of goods the vehicle can safely carry in accordance with its design specifications. Tare mass is determined by weighing the unladen vehicle on suitable vehicle scales. It is a legal requirement that this value, together with gross vehicle mass, be registered on the vehicle chassis frame. On an articulated vehicle, the combined mass of the prime mover and the semi-trailer must be registered. This is called the Registered Gross Combination Mass, or RGCM.
Vehicles can be described by the number of axles. Most light vehicles only have 2 axles. This vehicle has 4 wheels, but only 2 driving wheels. This one has 4 driving wheels and is commonly called a 4-wheel drive vehicle. On commercial vehicles, the load carried on a single axle is limited by law, so vehicles with extra axles are common. This layout has 6 wheels to support the vehicle, but only 2 drive it. The extra axle at the rear is only used to support the weight of the vehicle. This extra axle is sometimes called a lazy axle. This is called a 6x2 vehicle. If the lazy axle is changed to a driving axle, this becomes a 6x4 vehicle. Some heavy goods vehicles have an extra steering axle, which allows more weight to be carried. Find 5 vehicles with different numbers of axles and describe how they are used. The location of the driving axle determines whether the vehicle is classified as rear-wheel drive, front-wheel drive, four-wheel drive, or all-wheel drive. Rear-wheel drive vehicles can use a conventional layout with the engine at the front of the vehicle. The torque from the engine is transmitted to the rear-mounted driving axle by propeller or drive shaft. This spreads the weight of components throughout the vehicle. This rear-wheel drive vehicle has the engine at the rear, driving the wheels through a combination transmission and rear axle called a transaxle. The transaxle is lighter than a separate transmission and rear axle. Moving the engine to the rear allows a lower bonnet line, which improves aerodynamics. The increase in weight over the rear wheels can improve their traction. This vehicle has the engine located behind the operator's cabin, but forward of the rear driving axle. This is called a mid-engine rear-wheel drive vehicle. A mid-engine design locates the mass of the engine behind the driver but forward of the rear axle. This allows for a low bonnet profile and good handling. Most goods-carrying rigid commercial vehicles locate the engine near the front and drive the rear axle by a 2-piece propeller shaft. The rear axle supports most of the goods or payload. Minibuses commonly locate the engine at the front of the vehicle, beneath the operator's cabin, and drive the rear axle by a propeller shaft. Larger buses and coaches locate the engine at the rear. This allows the vehicle to have a low floor and removes much of the noise and vibration from the passenger compartment. Front-wheel drive vehicles use the front wheels to pull the vehicle along. In light passenger vehicles, it gives lighter body weight and increased interior room. The engine and transaxle are at the front and can be mounted laterally, that is, the engine is parallel to the front axle, or longitudinally, where the engine is in line with the center line of the vehicle. Make a list of current vehicles and classify them according to whether they are rear-wheel drive, front-wheel drive, four-wheel drive or all-wheel drive. This section examines engine and transmission configurations. An engine can be located at the front, middle, or rear of a vehicle. An engine located at the front can be mounted longitudinally and can drive either the front or the rear wheels. In four-wheel drive applications, it can drive both the front and rear wheels. Alternatively, the engine can be transverse and drive either the front wheels only, or in four-wheel drive applications, the front and rear wheels. Mid-engine vehicles have the engine in front of the rear wheels. The engine can be transverse or longitudinal and usually drives the rear wheels only. Rear-engine vehicles have the engine mounted behind the rear wheels. The engine can be transverse or longitudinal and usually drives the rear wheels only. The drivetrain transfers turning effort from the engine to the driving wheels. A drivetrain can include a clutch for manual transmission or a torque converter for automatic transmission. A transmission, a drive shaft, final drive, and differential gears, and driving axles. Alternatively, a transaxle may be used. A transaxle is a self-contained unit with the transmission, final drive gears, and differential located in one casing. It is usually used on front-engined, front-wheel drive vehicles or rear-engined, rear-wheel drive vehicles. It can also be used on front-engine, rear-wheel drive vehicles connected to the engine by a propeller shaft. A vehicle with a manual transmission uses a clutch to engage and disengage the engine from the drivetrain. Engine torque is transmitted through the clutch to the transmission or transaxle. The transmission contains sets of gears that increase or decrease the torque before it is transmitted to the rest of the drivetrain. The lower the gear ratio selected, the higher the torque transmitted. A vehicle starting from rest needs a lot of torque, but once it's moving, it can maintain speed with only a relatively small amount of torque. A higher gear ratio can then be selected and engine speed reduced. A conventional vehicle with the engine at the front and driving wheels at the rear uses a drive shaft called a propeller shaft to transmit torque from the transmission to the final drive. The final drive provides a final gear reduction to multiply the torque before applying it to the driving axles. On front-engine rear-wheel drive vehicles, the final drive changes the direction of the drive by 90 degrees. Inside the final drive, a differential gear set divides the torque to the axles and allows for the difference in speed of each wheel when cornering. Commercial vehicles may use a two-speed final drive. The low range provides more torque for lower speeds and heavy loads. High range is used for higher speeds and light loads. Axle shafts transmit the torque to the driving wheels. In a rear-wheel drive vehicle, the axles can be solid or contain joints to allow for movement of the suspension. For a front-wheel drive vehicle, the drive shaft has universal joints to allow for suspension and steering movement. An automatic transmission or transaxle performs similar functions to a manual transmission or transaxle, except that gear selection is controlled either hydraulically or electronically. The automatic transmission uses a torque converter, which acts as a hydraulic coupling to transfer the drive. A four-wheel drive vehicle has a propeller shaft, a final drive and differential gears, and axles for both the front and rear axle assemblies. A transfer case is attached to the transmission. Part-time four-wheel drive means the vehicle is usually in two-wheel drive and switch to full-time when needed by engaging the transfer case. It locks the propeller shafts together and directs torque through them to both axles. When disengaged, the vehicle transfer case is coupled to one propeller shaft only. When four-wheel drive is disengaged, most part-time four-wheel drive vehicles drive the rear wheels. Constant four-wheel drive uses a third differential in the transfer case. It allows for the difference in speed between the front and rear wheels during cornering. The driver can still lock the front and rear axles together by moving a separate lever as in a conventional four-wheel drive, or by moving the main gear selector. This is called a differential lock. Some full-time four-wheel drive sedans use a front engine and transaxle, with a propeller shaft connected to drive the rear wheels. These cars are lighter and less rugged than conventional off-road types, and usually operate at higher speeds. The drive to all wheels provides better balanced handling and traction for cornering in slippery conditions. This section examines steering systems. The direction of motion of a motor vehicle is controlled by a steering system. A basic steering system has three main parts: a steering box connected to the steering wheel, the linkage connecting the steering box to the wheel assemblies at the front wheels, and front suspension parts to let the wheel assemblies pivot. When the driver turns the steering wheel, a shaft from the steering column turns a steering gear. The steering gear moves tie rods that connect to the front wheels. The tie rods move the front wheels to turn the vehicle right or left. There are two basic types of steering boxes: those with rack and pinion gearing and those with worm gearing. In both cases, the gearing in the steering box makes it easier for the driver to turn the steering wheel and hence the wheels. A rack and pinion steering system has a steering wheel, a main shaft, universal joints, and an intermediate shaft. When the steering is turned, movement is transferred by the shafts to the pinion. The pinion is meshed with the teeth of the rack, so pinion rotation moves the rack from side to side. This type of steering is used on passenger vehicles because it is light and direct. This steering system has worm gearing. It provides a gear reduction and a 90-degree change in direction. It has more parts and joints than the rack type, but it is more robust and may be used on heavier vehicles. To allow the heavy transport vehicles to carry extra weight, two steering axles may be used. They're connected by a link to a common steering box. These vehicles are called tandem or twin-steered vehicles. Some passenger vehicles also steer the rear wheels slightly. This gives improved maneuverability. The system is known as four-wheel steering. It can be controlled mechanically through a direct connection between the front and rear steering boxes, or it can be computer-controlled. With heavier vehicles, increased use of front-wheel drive and wider low-profile tires, more steering effort is needed, so power steering is used. An engine-driven hydraulic pump provides pressure that helps the driver steer the vehicle. The power steering system is designed so that the vehicle can still be controlled, even if the engine or the power steering system fails. This section examines suspension systems. The purpose of the complete suspension system is to isolate the vehicle body from road shocks and vibrations, which would otherwise be transferred to the passengers and load. It must also keep the tires in contact with the road, regardless of road surface. A basic suspension system consists of springs, axles, shock absorbers, arms, rods, and ball joints. The spring is the flexible component of the suspension. Basic types are leaf springs, coil springs, and torsion bars. Modern passenger vehicles usually use light coil springs. Light commercial vehicles have heavier springs than passenger vehicles and can have coil springs at the front and leaf springs at the rear. Heavy commercial vehicles usually use leaf springs or air suspension. Solid or beam axles connect the wheels on each side of the vehicle. This means the movement of a wheel on one side of the vehicle is transferred to the wheel on the other side. With independent suspension, the wheels can move independently of each other, which reduces body movement. This prevents the other wheel being affected by movement of the wheel on the opposite side, and this reduces body movement. When a wheel strikes a bump, there is a reaction force, and energy is transferred to the spring, which makes it oscillate. Oscillations left uncontrolled can cause loss of traction between the wheel and the road surface. Shock absorbers dampen spring oscillations by forcing oil through small holes. The oil heats up as it absorbs the energy of the motion. This heat is then transferred through the body of the shock absorber to the air. When a vehicle hits an obstruction, the size of the reaction force depends on how much unsprung mass is at each wheel assembly. Sprung mass refers to those parts of the vehicle supported on the springs. This includes the body, the frame, the engine, and associated parts. Unsprung mass includes the wheels, tires, brake assemblies, and suspension parts not supported by the springs. Vehicle ride and handling is improved by keeping unsprung mass as low as possible. Wheel and brake units that are small and light follow the road contours without a large effect on the rest of the vehicle. Discover 5 current vehicles that use 5 different suspension systems. This section examines wheels. Wheels must be strong enough to support the vehicle and withstand the forces caused by normal operation. At the same time, they must be as light as possible to help keep unsprung weight to a minimum. Wheels can be made from pressed steel in 2 sections: the flange or disc that is drilled for the wheel fasteners, and the rim. Wheels can also be made from cast aluminium alloy. Alloy wheels are popular because of their appearance and because they are lighter than similar steel wheels. Aluminium is a better conductor of heat, so alloy wheels can dissipate heat from brakes and tires more effectively than steel ones. These are often called mag or magnesium wheels, but wheels made of magnesium are rarely used on road vehicles. Most wheels have ventilation holes in the flange, so air can circulate to the brakes. Most passenger car wheels are of well or drop center design. This design allows for tyre removal and fitting. Tyres for heavy goods vehicles are much stiffer, but they can also be fitted to a well-based rim or to a flat-based detachable flange rim, depending on construction. This section examines tyres. The tyre provides a cushion between the vehicle and the road to reduce the transmission of road shocks. It also provides friction to allow the vehicle to perform its normal operations. Modern tyres are manufactured from a range of materials. The rubber is mainly synthetic. Two types of tyre construction are common: cross-ply and radial. Most passenger cars now use radial tyres. And radials are replacing cross-ply tyres on four-wheel drives and heavy vehicles. Tube tyres require an inner tube to seal the air inside the tyre. Tubeless tyres eliminate the inner tube by making the complete wheel and tyre assembly airtight. A special airtight valve assembly is needed. This can be a tight fit into the rim, or it can be held with a nut and sealing washers. Tyres can be identified by markings on the sidewalls. This typically includes the maker's name, the rim size, the type of tyre construction, aspect ratio, maximum load and speed, and in some cases, intended use. Regulations cover the allowable dimensions for wheels and tyres on a particular vehicle. These dimensions are usually set out on the tyre placard attached to the vehicle. Incorrectly selected wheels and tyres can overload wheel bearings and change steering characteristics. The tyre placard lists the wheel and tyre sizes approved by the manufacturer for the vehicle. Using other wheels and tyres may be illegal. List allowable tyre and wheel sizes for 3 different vehicles using the tyre placard recommendations. This section examines drum, disc, and anti-lock brakes. Drum brakes have a drum attached to the wheel hub, and braking occurs by means of brake shoes expanding against the inside of the drum. With disc brakes, a disc attached to the wheel hub is clamped between 2 brake pads. On light vehicles, both of these systems are hydraulically operated. The brake pedal operates a master cylinder. Hydraulic lines and hoses connect the master cylinder to brake cylinders at the wheels. Most modern light vehicles have either disc brakes on the front wheels and drum brakes on the rear, or disc brakes on all 4 wheels. Disc brakes require greater forces to operate them. A brake booster assists the driver by increasing the force applied to the master cylinder when the brake is operated. The anti-lock braking system prevents wheel lock or skidding, no matter how hard brakes are applied or how slippery the road surface. Steering stays under control and stopping distances are generally reduced. It consists of a brake pedal, a master cylinder, wheel speed sensors, the electronic control unit or ECU, and the hydraulic control unit, also called a hydraulic modulator. List 5 passenger vehicles and discover the types of brakes they use. This section examines air brakes. Air-operated braking systems are used on heavy vehicles. Compressed air operating on large diameter diaphragms provides the large forces at the brake assembly that are needed. An air compressor pumps air to storage tanks. Driver-controlled valves then direct the compressed air to different wheel units to operate the friction brakes. On articulated vehicles, any delays in applying the trailer brakes should be minimized. This is achieved using a relay valve and a separate reservoir on the trailer. This arrangement also applies the brakes if the trailer becomes disconnected from the prime mover. This section examines exhaust brakes. Heavy goods vehicles can often require increased braking in situations where friction brakes could overheat and fail. This is achieved by using an exhaust brake. An exhaust brake works by restricting the flow of exhaust gases through the engine. It achieves this by closing a butterfly valve located in the exhaust manifold. This maintains high pressures in the exhaust manifold and the engine cylinders, which in turn acts as a brake against the engine rotating. This then slows the road wheels through the transmission or powertrain. Other heavy goods vehicles use an engine brake that operates by altering valve timing and stopping fuel being injected into the engine. This section examines electric brakes. Trailers and caravans towed by light vehicles must have a braking system if the trailer gross mass exceeds a certain value. An electric braking system is commonly used to activate the drum-type friction brakes on the trailer. Braking effect can be increased or reduced by the driver adjusting a control unit to suit the load on the trailer. When the brakes in the towing vehicle are applied, the brake light circuit sends the signal to the control unit. The control unit then sends an appropriate current to the trailer brake actuators to operate the trailer brakes at the level selected. This section examines the emergency brake. All vehicles must be fitted with at least two independent systems. They were once called the service brake and emergency brake. Now, they are usually referred to as the foot brake and the park brake. Most light vehicles use a foot brake that operates through a hydraulic system on all wheels, and a hand-operated brake that acts mechanically on the rear wheels only. One common use of the handbrake system is to hold the vehicle when it is parked. The systems are designed to be independent so that if one fails, the other is still available. A sedan has an enclosed body with a maximum of 4 doors to allow access to the passenger compartment. The design also allows for storage of luggage or other goods. A sedan can also be referred to as a saloon and traditionally has a fixed roof. There are soft-top versions of the same body design except for having 2 doors, and these are commonly referred to as convertibles. List 5 different sedans. Investigate their similarities and differences. A station wagon or estate car has increased luggage capacity and a large rear door for access. The rear seats can usually be folded to increase luggage capacity even further. The roof is usually fixed. List 5 different makes and models of current station wagons. Investigate their similarities and their differences. A coupe has just 2 doors. Reducing the number of doors to the passenger compartment makes the vehicle structure more rigid. Traditionally, it has 2 seats, with 2 smaller seats behind for occasional use. In this form, it is a close-coupled 4-seater and can be made in a fixed head or drop head configuration. A coupe is now regarded as being any fixed-head vehicle with two doors. List 5 different makes and models of current coupes. Investigate their similarities and their differences. What differences, if any, are there between coupes and sports cars? Hatchbacks can have 3-door and 5-door designs. Rear seats usually fold down to increase luggage area. They combine the benefits of sedans and station wagons to make more versatile vehicles. Five different makes and models of current hatchbacks. Investigate their similarities and their differences. Investigate manufacturer specifications to discover typical design differences between hatchbacks and station wagons. The utility or pickup carries goods. Usually it has stronger chassis components and suspension than a sedan to support greater gross vehicle mass. List 5 different makes and models of current utilities. Investigate their similarities and their differences. Light vehicle vans can be based on common sedan designs, or redesigned so that maximum cargo space is available. List 5 different makes and models of current light vehicle vans. Investigate their major similarities and differences. The bodies of commercial vehicles that transport goods are designed for that specific purpose. Tankers transport fluids. Tippers carry earth or bulk grains. And flatbeds and vans are used for general goods transport. A goods transport vehicle can be a rigid vehicle with a trailer, or an articulated vehicle. Articulated vehicles carry goods on a semi-trailer, with the power unit or prime mover connected to the semi-trailer by a coupling called a fifth wheel coupling. The fifth wheel coupling lets the traction unit pivot on the semi-trailer. This gives more maneuverability than with rigid vehicles or rigid trailer combinations. A road train connects extra trailers by a small interconnecting trailer called a dolly. It has a fifth wheel coupling and it's connected to the leading trailer by a drawbar. Up to 3 trailer and dolly sets can be drawn by one prime mover, and each set contains brakes for each wheel and lights for each trailer. A B-double vehicle has a fifth wheel on the rear of the first trailer, and the second trailer is coupled to the fifth wheel. This removes the dolly wheels from the combined unit, which reduces the length of the vehicle. But since there are fewer supporting wheels, the vehicle payload is also reduced. Heavy goods vehicles can have normal control with the operator seated behind the engine. A lightweight bonnet that can be tilted or raised allows easy access to the engine for servicing. In forward control, the operator cabin is mounted over the engine. This design gives greater load length to the vehicle. The cabin can be tilted for easy access to the engine. Some designs only have a hinged flap over the engine bay. Investigate basic uses of different kinds of goods-carrying vehicles, including a rigid vehicle with a trailer, and an articulated vehicle. List examples of different makes and models of goods-carrying vehicles. Compare any basic similarities and differences. For instance, rigid or articulated, body types, and goods carried. Buses and coaches are usually four-wheel rigid vehicles, but a larger number of wheels and axles can be used. Sometimes articulated buses are used to increase capacity. Buses and coaches can be single-deck or double-deck. Buses are commonly used in cities as commuter transport, while coaches are more luxurious and used for long distances. Use manufacturer specifications to investigate differences and similarities between a common model bus and a coach.